Now we discuss some more concepts: rational number and irrational number, right? Rational number and irrational number. Right. What is rational number? First we discuss rational number, then later irrational number. So what is rational number? A number which denotes in the form of p by q, right? P and q are integers and q is not equal to 0, right? In another way, what we can say, a set of rational numbers encloses the set of integers and fractions, right? Set of integers and fractions. What we discussed in the number chart, right? If you remember, these rational numbers are classified into two more parts: integers and fractions, right? The same thing I have written here. The set of rational numbers encloses the set of integers and fractions, right? The other property is rational number can be written as ratio, right? Can be written as ratio. Ratio is nothing but simple fraction, right? Ratio is nothing but simple fraction, right? If suppose 1.5, how can I write 15 by 10? So 3 by 2 or 3 is to 2. 3 is to 2 is the ratio, 3 by 2 is the fraction, right? Fraction and ratio is one and same. So 1.5 is the rational number. 7, is it rational or not? Yes. 7 also rational number because 7 by 1. If nothing is the denominator, you need to think that there is a 1, right? 7 by 1. So it is a rational number, right? Another example, 2 by 3, 0.66666. Even repeating, you can write in the fraction. So this 2 by 3 is a rational number, right? Right. Few numbers cannot be expressed in ratio. Few numbers cannot be expressed in ratio, right? Or fraction. So that numbers are called irrational numbers, right? Understand? In another way, you can say other than rational numbers or irrational numbers, right? For example, root 2. Can you express it in a ratio? No. That is the reason it is a irrational number. Pi, what is the value of pi? 3.14159263. It is going on, right? The value of e, what is the value of e, right? 2.71828182. There is a some number, right? This 7182818, so on, right? This pi also, no, 3.142859, so on, right? And the note, when you multiply some irrational numbers with other irrational number, it might be rational number. See, root 2 into root 2, what you get? 2. This is rational number, right? Similarly, root 5 into root 10, if you make it root 50, but you get 25 into 2, right? 5 root 2. Again, it is irrational, right? Root 10 into root 10, you get 10, then it is a rational number, right? Clear? This is the concept of the rational and irrational, right? Now we'll move to the other concept, real numbers, right? Real numbers. What is real numbers? Whatever we have discussed, all the things now, that comes under the real numbers, right? Real numbers are divided into rational, irrational. Again, rational is divided into integers, fractions. Again, fractions, sorry, integers divided into whole numbers and zero, right? So so that all numbers come under the real numbers. To say simple, all numbers represents all numbers represents on the number line, on the number line are called real numbers, right? Are called the real numbers, right? So it can be 2, 3, root 3, root 2, right? Minus 3, 3 by 2. These are all called the real numbers, right? Next, complex number, right? What is the complex numbers, right? At the time of discussion of number chart, what we have discussed, it is the combination of real numbers and imaginary number, right? It can be expressed in the terms a plus ib, right? Where a and b are real numbers, a and b are real numbers, and I is imaginary number, right? What we have discussed, I is an imaginary number, right? So I square equal to minus 1, that is I equal to root of minus 1, right? Right. Now we see these some properties on complex numbers, right? So complex number will be in the form of a plus ib, right? If I write in the number example 3 plus 5i, right? This part is real part and this part is imaginary part, right? It calls as imaginary part, right? I equal to root of minus 1, I square equal to minus 1, right? I cube equal to, how we can write the I cube? I into I square, right? So I square, I know the value of I square is minus 1, so I cube value is minus I. What is the value of I? 4, I power of 4. So I can write I square whole square. I know I square is minus 1, right? Minus 1 whole square equal to 1, right? Now if I give I power of 240, what will be the value of I power of 240? Tell me, ma. What will be the value of I power of 240? Right. 240. See, I know I power of 4 is always 1. If I check it whether the power is divisible by 4 or not, right? If it is divisible by 4, then that value is 1, right? Suppose if I take I power of 39, right? I power of 39. How can I write? 36 into I power of 3. Right or wrong? So I power of 36 value will be 1. So I cube minus I. So I power of 39 value will be minus I. So see, if I take 69, right? I know that I power of 4 is 1. So whichever the number divisible by 4, that will be 1. So I can write directly I power of 64 is divisible by 4. So that is the value of I power of 64 is 1. So what it is remain? Okay, right. I power of 68. Till we have the 68, right? Just divide the power with 4. Right? How many times? 17 times. Right? What is the remainder it is was left? 1. So the answer will be I. So the value of I power of 69 is I. Right. Next we see conjugate of complex number. Right? We see conjugate of complex number. Right. First of all, what is complex number? A plus bi. This is complex number, right? What is conjugate of complex number? A minus bi. That's all. This is the conjugate of complex number, right? If we multiply both the numbers, right? If I multiply both the numbers, what I get? We will see it. A square minus abi plus abi minus bi square, right? So I get a square minus bi square. I square I know minus 1. Sorry, this is b square, right? B square I square. So a square plus b square. So when we multiply conjugate and the complex number, we get the result a square plus b square. A very important point, guys. Right. Right. Now we do one problem. Right. 3 plus 5i by 2 minus 3i. Do the division. Right. Do the division. How you do? Right. So 3 plus 5i by 2 minus 3i into 2 plus 3i by 2 plus 3i. Right. Now the upper part will be 3 plus 5i into 2 plus 3i by 2 minus 3i by 2 plus 3i. Right. What the result we got? A square plus b square. Actually, in natural numbers, what we do? A minus b into a plus b, a square minus b square. The same thing we do here, right? You can apply that thing also. But if you remember this formula, directly you can write that answer, right? 6 plus 9i plus 10i plus 15i square, right? By a square plus b square, a square 4 plus 9, that's all, right? So 6 plus 19i, so 15i squared, so minus 15 plus 6 minus 9, so 19i minus 9 by 13, right? Or you can write in this way, 9 by 13 plus 19i by 13, right? Got it? Clear? Right. Shall we do one more example? Right. Example. What is the value of root minus 1 4n plus 1 plus root minus 1 4n plus 3, where n is a natural number. Right? Right. Now we will do the solution. Right. What the question he has given? Root of minus 1 whole power of 4n plus 1 plus root of minus 1 4n plus 3, where n is a natural number. Right? Right. Root of minus 1, I will put this 4n plus 1 like this, plus root of minus 1, I will make it 4n plus 1 into root of minus 1 whole square. Right? Can I write or not? When bases are equal, you can add the powers, right? 4n plus 1 I made into root of minus 1 into 2, right? Now I will make root of minus 1 4n plus 1 as a common. So 1 plus root of minus 1 whole square, right? So root of minus 1 4n plus 1, then 1 plus root of minus 1 whole square minus 1. So 1 minus 1 0. So the answer is 0, right? Clear? Good. We have completed all the definitions shown in the number chart, right? Now we will discuss one more number, which is consecutive number, right? That which is not seen in the number chart, right? The other concept, consecutive number, right? What is consecutive number? Right? What is consecutive number? Tell me, ma. What is consecutive number? Right? You are saying the examples, right? 10, 11, 12, 13, 14, so on, right? These are called the consecutive numbers. Then what is this? Is this also called the consecutive numbers? Right. What we are seeing? A series of numbers. We are seeing a series of numbers. We are seeing a series of numbers in which what we are seeing? A series of numbers in which the next number is one more than the previous number, right? In which the number is one more than the previous number, right? These are called the consecutive numbers, right? In consecutive numbers, we have three types, right? One, consecutive natural numbers. Consecutive numbers or consecutive natural numbers one and same. If nothing is mentioned in the question, then it is consecutive natural numbers only, right? And other one, consecutive even numbers, right? Consecutive even numbers. And third, consecutive odd numbers, right? Consecutive odd numbers. So consecutive natural numbers, already we have discussed 10, 11, 12, 13, 14. These are called the consecutive natural numbers. Consecutive even numbers. What do we have? 20, 22, 24, 26. These are called the consecutive even numbers. But there is a difference of 2. This is a number of series which the number is 2 more than the previous number. Then that is called the consecutive even numbers. Then what is the consecutive even numbers? 13, 15, 17, 19, 21. These are called the consecutive odd numbers. What is the difference? The difference for the even numbers is 2. For the difference in consecutive odd numbers also 2. But the numbers are odd, right? These called the consecutive odd numbers. These called the consecutive even numbers. Right. Now we see how we need to assume consecutive numbers. Right. First we see the consecutive natural numbers. Consecutive natural numbers we can write in two ways. Right. First way we can write as the natural number x, first number will be x, then second number will be x plus 1, x plus 2, x plus 3, x plus 4. We assume that 5 consecutive natural numbers. Okay, if it is 6 then x plus 5. Then second way, the middle number will be the x. We can assume that middle number as x. Right. Then here we will write x minus 1, then this side x plus 1. And if you write here x minus 2, then you will write here x plus 2. This is the second way how we need to assume the consecutive natural numbers. Right. This is the easiest way to reduce the calculation. Right. If I need 5 consecutive even numbers, if I need 5 consecutive even numbers, right, one way you can write x, x plus 2, x plus 4, x plus 6, x plus 8. The second way is the middle number will be always x, then x minus 2, x minus 4, then x plus 2, x plus 4, this way. Then the same thing will be applicable for the 5 consecutive odd numbers. Right. Shall we do one example? Right. Now see the question. The sum of 5 consecutive odd numbers is 155. What is the largest number? Right. We will do in two ways. Right. Right. He told that what is the largest number. Right. I will take 5 consecutive numbers as x, x plus 1, x plus 2, x plus 3, x plus 4. Right. What he gave? The sum of 5 consecutive odd numbers. Sorry, he told odd numbers, right? Right. So there should be a difference of 2. There should be a difference of 2. X plus 2, x plus 4, x plus 6, x plus 8. Right. These are the 5 consecutive odd numbers. If I do sum x plus 2, x plus 4, x plus 6, x plus 8, then the sum is 155. Right. So 5x plus 2, 4, 6, 12, 20. Right. 155. Then 5x equal to 135. Then x equal to 27. Right. Clear? Right. Now what is asked? Largest number. What is the largest number? X plus 8. So the largest number is 35. Right. This is the one method. Whenever the question is given for to find the consecutive odd numbers, I don't suggest this method. Right. The other method, x, x minus 2, x plus 2, x minus 4, x plus 4. Right. Now when you add these numbers, what you get? All cancelled. Right. All real numbers are cancelled. Right. It remains 5x equal to 155. Right. So x equal to 31. Right or wrong? So this value is 31. So what is the largest number here? X plus 4. So this should be 35. That's all. Simple. Right. The consecutive numbers concept is clear. No more doubts. Right. Good. Right. Now we see two properties of the consecutive numbers. Right. One, the product of three consecutive numbers 3 consecutive numbers is always divisible by 6, right? The product of 3 consecutive numbers always divisible by 6. Whenever I say consecutive numbers, it is consecutive natural numbers only, right? So what is the meaning of that example? Right, 3 consecutive numbers, you take any 3 consecutive numbers, 10 into 11 into 12, it is always divisible by 6, right? Is it divisible or not? Right, you take some other number, 21 into 22 into 23, right, by 6, right? See, 2 threes, 2 11s, and 3 7s, right? So the product of any 3 consecutive numbers, right, the product of any 3 consecutive numbers is always divisible by 6, right? The other property is the product of any or consecutive integers or numbers. The product of any or consecutive integers or numbers is divisible by or factorial. Okay, example, the product of any or consecutive integers, right? That means if I take any 5 consecutive integers, right, definitely it is divisible by 5 factorial, right? Any 5 consecutive integers, if I take 11 into 12 into 13 into 14 into 15, 1 2 3 4 5, these are the 5 consecutive integers, so definitely it will be divisible by 5 factorial. What is the value of 5 factorial? The value of 5 factorial is 120, right? So 5 factorial is nothing but we can write as 11 into 12 into 13 into 14 into 15 by 5 into 4 into 3 into 2 into 1, right? 5 threes, then 3 threes deducted, right? 4 threes, then 2 sevens, right? It is completely divisible, right? So these two properties are very, very important, right? For suppose the second one, the product of 4 consecutive numbers is divisible by 4 factorial. The product of 8 consecutive integers is divisible by 8 factorial. The meaning of the second point is that, right? Understood? Clear? The concepts are clear, right?